Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now, we are going to learn about how to find the stagnation point heating rate of space shuttle. Consider the space shuttle. During the entry of the space shuttle into the Earth's atmosphere, maximum stagnation point heating occurs at the trajectory point corresponding to an altitude of 68.9 km, where density is 1.075 into 10 to the power minus 4 kg per meter cube and a flight velocity of 6.61 km per second. At this point on its entry trajectory, the shuttle is at 40.2 degree angle of attack, which presents an effective nose radius at the stagnation point of 1.29 meter. If the wall temperature is 1110 Kelvin, calculate the stagnation point heating rate. Given data. Here, the space shuttle enters to the Earth's atmosphere. At an altitude of 68.9 km, density rho infinity is 1.075 into 10 to the power minus 4 kg per meter cube, and velocity of the space shuttle V infinity is 6.61 km per second. Angle of attack of shuttle on its entry trajectory alpha is 40.2 degree. At this point, nose radius r is 1.29 meter. Wall temperature T suffix W is 1110 Kelvin. Now, the question is, what is the stagnation point heating rate? The aerodynamic heating rate varies as the cube of velocity. We can write the heating rate at the stagnation point Q dot suffix W is equal to rho infinity power 0.5 into V infinity cube into 1.83 into 10 to the power minus 8 into r to the power minus 0.5 into 1 minus h suffix W divided by h naught, where rho infinity is the density of the fluid, which is known, and V infinity is the velocity of the given vehicle, which is also given in the question, and r is the nose radius at the stagnation point. H suffix W is the enthalpy of the gas at the wall. H naught is the total enthalpy of the free stream. Here we don't know the values of H suffix W and H naught. At hypersonic speeds, V infinity is very large. Also, the ambient air far ahead of the vehicle is relatively cool. Hence, enthalpy at wall H suffix W is equal to C suffix P into T suffix W is relatively small. Thus, at high speeds, the total enthalpy H naught is approximately equal to V infinity square divided by 2. Now, substitute the value of velocity in total enthalpy expression and solve. We get H naught is 2.185 into 10 to the power 7 joules per kilogram Kelvin. For wall enthalpy, when the wall temperature is 1110 Kelvin, we can reasonably assume a calorically perfect gas. For calorically perfect air, specific heat at constant pressure C suffix P is equal to 1004.5 joules per kilogram Kelvin. Simplify equation 3 with appropriate values. We get H suffix W is equal to 1.115 into 10 to the power 6 joules per kilogram Kelvin. Now solve the equation number 1 with suitable values. We get the required heating rate at the stagnation point of shuttle Q dot suffix W is 45.78 watt per centimeter square. Did you know a bird can take out a plane's engine? A bird strike happens when an aircraft and bird collide in the air. While these incidents are not uncommon, they usually don't do anything more than create a loud noise, rarely causing accidents. Still, pilots must go through rigorous training to deal with a bird strike. And in the event of a bird taking out an engine, they are trained on flying with only one engine. Bird strikes to both engines are very rare, but have happened. Remember the miracle on the Hudson? After the plane hit a flock of Canada geese and blew out both engines, Captain Chesley Sully Sullenberger safely landed on the Hudson River. During a 1994 flight, a mother tragically lost her grip on her infant daughter she was holding on her lap when the aircraft experienced violent gyrations. While the mother survived, her daughter died. Planes go through a decision process just seconds before landing. Just when an aircraft is about to land, pilots go through what is termed as the decision altitude or decision height. At this point, if they are able to see the runway and its lights, they can continue the descent. Else, they must report to ascend again and perform and go around.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.